Hello everyone, this is John's podcast. I'm your host, John Mark B. Ilag, a BS Ed 3 mathematics student. So for today's episode, we'll talk about Pythagorean Theorem. This podcast is designed for you to understand what is Pythagorean Theorem, its process, how to classify a triangle using Pythagorean Theorem, the use of it in real life, and so on. So, I hope you'll enjoy listening. I think the best way to start is to know what is Pythagorean Theorem is. The Pythagorean Theorem is a mathematical law that states the sum of squares of the lengths of the two short sides of a right triangle is equal to the square of the length of the hypotenuse. The Pythagorean Theorem, also referred to as the Pythagoras Theorem, is arguably the most famous formula in mathematics that defines the relationship between the sides of a right triangle. The theorem is attributed to a Greek mathematician and philosopher named Pythagoras in the year 569 to 500 before Common Era. He has many contributions to mathematics, but the Pythagorean theorem is the most important of them. The Pythagoras theorem is algebraically written as a squared plus b squared is equals to c squared. So where did they get a squared plus b squared is equals to c squared? One of the most common demonstrations of the Pythagorean theorem given by the different mathematicians is to draw three squares in such a way that they form a right triangle in between. And the area of the bigger square, the one at hypotenuse, is equal to the sum of the area of the two smaller squares, the ones on the two sides. They are drawn in such a way that they form a right triangle. We can write their areas in equation form. Area of square 3 is equals to area of square 1 plus area of square 2. Let's suppose that the square 1, square 2, and square 3 are a, b, and c respectively. Then, area of square 1 is equals to a squared, then area of square 2 is equals to b squared, and area of square 3 is equals to c squared. Hence, we can write it as a squared plus b squared is equals to c squared. There are different types of triangle. We can classify those triangles by using the converse of the Pythagorean theorem. The converse of the Pythagorean theorem is a rule that is used to classify triangles as either a right triangle, acute triangle, or an obtuse triangle. Given the Pythagorean theorem, a squared plus b squared is equals to c squared, then for an acute triangle, c squared is less than a squared plus b squared, where c is the side of the opposite acute angle. If c squared is less than a squared plus b squared, then the triangle is classified as an acute triangle. Example: classify a triangle whose side lengths are given as 11 inches, 13 inches, and 17 inches. We substitute 11 to a, 13 to b, and 17 to c. So using the Pythagorean theorem formula, which is a squared plus b squared is equals to c squared, we have 11 squared plus 13 squared. So we will have 121 plus 169. If we add those two numbers, we will get 290. Now we will get the value of c squared, which is 17 squared. 17 times 17 is equals to 289, which means c squared is less than a squared plus b squared, which is 289 is less than 290. C squared is less than a squared plus b squared, so a triangle whose side lengths are given as 11 inches, 13 inches, and 17 inches is a acute triangle. For a right triangle, c squared is equals to a squared plus b squared, where c is the side of the 90-degree angle. If c squared is equals to a squared plus b squared, then the triangle is classified as a right triangle. Like if a triangle whose side lengths ABC are 8 mm, 15 mm, and 17 mm respectively, using the Pythagorean theorem formula, a squared plus b squared is equals to c squared, we substitute 8 to a, 15 to b, and 17 to c. So we have 8 squared plus 15 squared is equals to 64 plus 225, which is equals to 289. Now the value of c squared is equals to 17 squared, which is 17 times 17 is equals to 289. So we compare the value of c squared and a squared plus b squared. So the value of a squared plus b squared is 289, and the value of c squared is also 289. Therefore, c squared is equals to a squared plus b squared. So the triangle whose side lengths ABC are 8 mm, 15 mm, and 17 mm is a right triangle. For an obtuse triangle, c squared is greater than a squared plus b squared, where c is the side opposite the obtuse angle. Example: if a triangle whose dimensions are a is equals to 5 meter, b is equals to 7 meter, and c is equals to 9 meter. Using the Pythagorean Theorem, a squared plus b squared is equals to c squared. We substitute 5 to a, 7 to b, and 9 to c. So we have 5 squared plus 7 squared, so we have 25 plus 49, which is equals to 74. Now for the value of c squared, which is 9 squared, 9 times 9 is equals to 81, which is c squared is greater than a squared plus b squared, which is 81 is greater than 74. Hence, c squared is greater than a squared plus b squared. So a triangle whose dimensions are a is equals to 5 meter, b is equals to 7 meter, and c is equals to 9 meter is an obtuse triangle. More about Pythagorean Theorem when we come back.
Welcome to Faith and Fury.
Thank you for listening to Give Me a Mulligan.
You know, you have your family, you have your friends.
Good Sunday morning, and thanks so much for joining us.
Click on the podcast, download it, and listen to the whole show.
So we are back here, listeners. Now, let's proceed to the next part of our topic. So the next topic is application of Pythagoras Theorem. So the next topic is the application of Pythagoras Theorem in real life. The Pythagoras Theorem formula is given as c squared is equals to a squared plus b squared, where c is equals to the length of hypotenuse, a the length of one side, and b is equals to the length of second side. We can use this formula to solve various problems involving right-angled triangles. For instance, we can use this formula to determine the third length of a triangle when the length of the two sides of a triangle are known. Here are the following use of Pythagorean Theorem in real life. First, we can use the Pythagoras Theorem to check whether a triangle is a right triangle or not. Second, we can use Pythagoras Theorem in oceanography. The formula is used to calculate the speed of sound waves in water. Third one, Pythagoras Theorem is used in meteorology and aerospace to determine the sound source and its range. Fourth, we can use the Pythagoras Theorem to calculate electronic components such as TV screen, computer screen, solar panels, and etc. We can also use Pythagoras Theorem to calculate the gradient of a certain landscape. In navigation, we can use the Pythagorean Theorem to calculate the shortest distance between given points. And in architecture and construction, we can use the Pythagorean Theorem to calculate the slope of a road, drainage system, dam, and etc. Example: the two short sides of a right triangle are 5 cm and 12 cm. Find the length of the third side. So using the Pythagorean Theorem formula, a is equals to 5 cm, b is equals to 12 cm, and c is the unknown. From the Pythagoras Theorem formula, we have c squared is equals to a squared plus b squared. We substitute 5 to a and 12 to b. So we have c squared is equals to 5 squared plus 12 squared. So 5 times 5 is equals to 25, and 12 times 12 is equals to 144. So if you add those two, we will get 169. So So c squared is equals to 169. So the square root of 169 is equals to 13. So the length of the third side of the triangle is 13. Therefore, the third side is equals to 13 cm. Another one. Find the size of a computer screen whose dimensions are 8 inches and 14 inches. The size of a computer screen is the same as diagonal of the screen. Using the Pythagorean Theorem, c squared is equals to a squared plus b squared is equals to c squared is equals to 8 squared plus 15 squared. So 8 times 8 is equals to 64, and 15 times 15 is equals to 225. C squared is equals to 289, and the square root of 289 is equals to 17. So the size of a computer screen whose dimensions are 8 inches and 14 inches is 17 inches. So that's it. You've reached the end of another episode of John's podcast with your host, John Mark Ilak. Thank you for listening. See you at the next episode. Bye!